Hey guys, it's Medicosis Perfectionalis, where medicine makes perfect sense, continuing our great playlist called Biochemistry. In previous videos, we have started Introduction to Biochemistry and we have compared between fat-soluble and water-soluble vitamin. Today I'll talk about vitamin B1, also known as thiamine. So let's get started. Why do we call them vitamins? Because supposedly they are vital amines, which is a wrong name. They are not amines, but the name stays. Organic molecules, micronutrients, they are essential, which means your body cannot make them, therefore you have to eat them. We have compared between water-soluble and fat-soluble vitamins in the previous video. I'm not going to repeat myself, but please subscribe and save this playlist called Biochemistry. Examples of water-soluble vitamins are vitamins B and C. How about the fat-soluble vitamins K, E, D, and A? B vitamins have 8 subtypes. Today's topic is B1, also known as thiamine. Just a quick review. Remember, vitamin C is responsible for collagen, so C is for collagen. When you have vitamin C deficiency, you get scurvy. This is another C. Vitamin K is for coagulation. Vitamin E is a great antioxidant. Vitamin D is good for your bone. And vitamin A is good for your retina, so that you may see. Let's talk about vitamin B. We have 8 members. B1, also known as thiamine. B2 is riboflavin. B3 is niacin. B5 is pantothenic acid or pantothenate. In biochemistry, most of the time, I can say pantothenic acid or I can say pantothenate, and they will mean exactly the same flipping thing. B6 is pyridoxine. B7 is biotin. B9 is the famous folate. B12 is cobalamin. Many students confuse between thiamine and thiamine. No, there's a big difference between them. Thiamine is vitamin B1. It's a water-soluble vitamin. Thiamine is a nitrogenous base, a nucleobase in the nucleotide in the DNA structure. Because on your exam, this word is just going to be written on a piece of paper or on a stupid computer. Your professor is going to come and say, oh, by the way, by thiamine, I mean the vitamin B1. Yeah, do not confuse it. Nobody's going to do this because no one cares. So thiamine, which is in the DNA, which is not today's topic, is a nitrogenous base. And of course, A goes with the T and G goes with the C. And this is your beautiful DNA double helix. Thanks, Watson. Thanks, Craig. B1, also known as thiamine, sources: liver, eggs, cereal, wheat, rice which is not refined, I mean whole grain, because when it goes to the factory it starts brown, okay, or brownish or dark yellowish. This is the wheat/rice. Then in the factory they do a refining process. They remove the outer layer of the grain, and then it becomes white rice or white bread. This is deficient in thiamine. So by wheat and rice, I mean the non-refined, I mean the whole grain, wheat or rice. Also brewer's yeast, meats and nuts. The most common cause of vitamin B1 deficiency worldwide is eating white refined rice. White rice, beriberi. Stimulus response. Let's do this Pavlovian experiment. When I say white rice, beriberi. When I say white rice, vitamin B1 or thiamine deficiency. I've told you about this great story in history about Dr. Takaki Kanehiro, who observed that the sailors of the Imperial Japanese Navy can be divided into 2 groups. First group, who were poor, could only afford to eat white rice. This is that refined rice that's vitamin B1 deficient. But the rich folks could afford meat, fish, beans, chicken, greens, vegetables, yeast, etc., and nuts, etc., etc. So they were fine, but the poor sailors developed beriberi, vitamin B1 deficiency. And we have 2 types. We have the dry beriberi and we have the wet beriberi. Dry is usually neuropathy. Wet beriberi is usually dilated cardiomyopathy. Neuropathy, dilated cardiomyopathy. Musical, beautiful, sticks in the memory, sticks in your hippocampus. My style in my videos will either make you love me or hate me, both of which are good for your hippocampus. A student might say to me, hey, I'm from New Hampshire, United States. I have never tried the whole grain bread before. All the bread that I eat is refined, the white bread. Am I going to die? Shut up. In the United States, they have enriched the flour with vitamin B1. As you see here, this is thiamine, so this is B1. Niacin is B3. and riboflavin is B2, and folic acid is B9. And this is my loaf of bread that I got from the store for 60 cents because it was discount. But this was not whole grain, so I had to check the label. And I looked at this and it was enriched with vitamin B1, so I said, okay, now I'm safe. Thank you so much, Sam Walton. May he rest in peace. 60 cents for all of these goodies. Amazing. Now, some of you online gurus would like to spend $5 for a loaf of bread from a top-notch grocery store. You can do whatever you want to do with your life. You are paying 5x for the exact same flipping nutrients. Personally, I like to save money because there is an opportunity cost to money. A money that's spent on bread unnecessarily is money that could have been donated to charity, could have been used to help my mom, could have been used to help my family, could have been used to do many stuff in life. Thiamine is either thiamine monophosphate or thiamine diphosphate. Clinically speaking, we couldn't care less about thiamine monophosphate. Forget it. All the goodies come from the thiamine diphosphate, aka thiamine pyrophosphate. And if you have purchased my Electrolytes course from my website, I have talked about phosphate for a very long time. One of the important things about phosphate that it helps in thiamine pyrophosphate, which is a cofactor for bazillion enzymes, which is good for you. Thiamine, B1, thiamine diphosphate or pyrophosphate is what we care about. Functions, cofactor/coenzyme in biochemical reactions producing what? ATP, the energy currency in your body so that you may live. Okay, what is the function again of thiamine? Transfer of 2 carbon units. We call this a dehydrogenase enzyme. In other words, vitamin B1 helps with that dehydrogenase enzyme. It helps them, it assists them. Dehydrogenase, what the flip is a process of dehydrogenation. It's decarboxylation followed by conjugation with a coenzyme A. Decarboxylation, you remove that COO terminus, and where I grew up, you can combine them together and call it CO2. So you're removing CO2 and adding a CoA, coenzyme A. This is called dehydrogenase. And as you see, it's a 2 carbon unit. The first enzyme is pyruvate dehydrogenase. Does it have dehydrogenase? Yes, therefore it needs thiamine or vitamin B1. What do you mean by dehydrogenase? Decarboxylation first, then conjugation with the CoA. And pyruvate dehydrogenase is key in glycolysis, specifically the step between glycolysis and the Krebs cycle. Alpha-ketoglutarate dehydrogenase again is dependent on the freaking thiamine. Next, we have branched chain alpha-keto acid dehydrogenase, also dependent on vitamin B1 as a cofactor. Transketolase in the HMP shunt, also as the pentose phosphate pathway, and this transketolase also needs some vitamin B1, baby. Also some enzyme that I don't care about, it's called 2-hydroxy, whatever, you can read it, I don't give a rip. Let's talk about your body. First, you eat. Why do you eat? Because you need energy. It's called ATP, baby. The best source of energy for your brain is actually glucose, which comes from carbohydrate. So you eat carbohydrates such as the delicious loaf of bread that I got from Sam Walton, may he rest in peace, which will give you glucose because, in your intestine you are breaking down the complex stuff, such as the carbohydrate, into very simple stuff, such as glucose. Then the glucose will go into the cell, a process called glycolysis, and it will produce pyruvate. Pyruvate has 4 options in life. It doesn't lack options, baby. It can either be acetyl-CoA, go to the Krebs cycle to produce ATP, which is awesome. If you happen to have oxygen, this is called aerobic reaction. If you are poor and you have no oxygen, that's an anaerobic glycolysis. It's going to produce lactate, also known as lactic acid. This lactic acid can lead to lactic acidosis, which will lead to a high anion gap metabolic acidosis or HAGMA. And as you know, acidosis inhibits the neurotransmitters in your brain, and it makes you drowsy, lethargic, tired, etc. That's why people who are on keto diet think they are arrived to the ultimate purpose in life, and the keto diet is the best thing ever. Keto diet causes ketosis, which is a freaking metabolic acidosis. That's why many of them are tired, lethargic, drowsy, etc., 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 because there are no solutions in life. There are only trade-offs, as the Dr. Thomas Sowell said. What other options do you have? Pyruvate. I can also become oxaloacetate. I can help you make some fatty acid through Krebs cycle, or I can make you some gluconeogenesis, which is an absolutely brilliant term. Genesis means creation, neo means new, and gluco means glucose. I'll make glucose from new sources. What do you mean by new sources? I mean lipids and proteins. Do you have any other options? Yes, I can become alanine, and I need the great liver enzyme alanine transaminase. And it needs vitamin B6. By the way, ALT is one of the enzymes that you test for when you do liver function test. The other one is called AST, aspartate transaminase, or aspartate aminotransferase, which means exactly the same thing. Back to our story. When you have oxygen, acetyl-CoA, baby, and I'm gonna produce 2-NADH, which is awesome because the 2-NADH will go to the electron transport chain and will give us some gold, some ATP. It's gonna give us money. Acetyl-CoA will go to the Krebs cycle, producing 6-NADH and 2-FADH2. All of them will go to the electron transport chain in the freaking mitochondria to produce money. This great enzyme that converts pyruvate into acetyl-CoA is called pyruvate dehydrogenase. When you hear the word dehydrogenase, you can assume that it's gonna throw carbon dioxide out in the trash and add a coenzyme A. That's why it's called acetyl-CoA, baby. Biochemistry makes perfect sense with medicosis perfectionalis. Here is the story of your life. You either eat carbohydrate or protein or fat, or you drink alcohol. Carbohydrate, glucose, pyruvate into acetyl-CoA, Krebs cycle or TCA cycle, ATP. Thank you so much. This is excellent. If you eat protein, amino acids, some of them will give you acetyl-CoA, TCA cycle, ATP. Brilliant. Lipids, you get free fatty acid and ketone bodies. Both of them can lead to acetyl-CoA. Citric acid cycle, ATP. Boom. If you drink alcohol, ethanol can give you acetyl-CoA, Krebs cycle, ATP. Boom. Let's talk about calories per gram. Proteins will give you 4 calories per gram of protein. Carbohydrate, also 4. How about fat? 9, baby. Alcohol is 7. So I ate some carbohydrate, got some glucose, became pyruvate through glycolysis. Now the pyruvate is going to become acetyl-CoA. Acetyl-CoA will go to the TCA cycle to make some energy. Good. What's the enzyme here? It's called pyruvate dehydrogenase, which means it's going to remove carbon dioxide and add a coenzyme A. It needs 5 flipping cofactors. Number 1 is thiamine pyrophosphate, because no one cares about the monophosphate. Thiamine is the same as B1. Also, it needs FAD, which comes from riboflavin, which is the same thing as vitamin B2. NAD, which comes from niacin, which is the same thing as B3. Lipoic acid and CoASH. This CoASH is pantothenic acid or pantothenate, which is the same thing as saying vitamin B5. Those 5 cofactors will be repeated many times in biochemistry. That's why here is my mnemonic. You know the company Tefal? Yes, your nice frying pan. It's made of Tefalone. So Tefalone Company. Just do Tefalone Company. TFLN and Company. So T is for thiamine, F is for FAD and for riboflavin, L is for lipoic acid, N is for NAD and niacin, and CO is for the famous CoASH. You eat carbohydrate, it becomes glucose, it becomes pyruvate through glycolysis, which becomes acetyl-CoA, thanks pyruvate dehydrogenase and the 5 coenzymes. And then we go to the TCA cycle. Citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA, and we'll continue later. Alpha-ketoglutarate to succinyl-CoA needs alpha-ketoglutarate dehydrogenase. When you hear the word dehydrogenase, you can be sure that's going to kick CO2 to the trash and bring a coenzyme A into the equation. Since this is also a dehydrogenase, it needs vitamin B1, but not just vitamin B1, the whole gang, the Teflon Company. TFLNCO. T is for thiamine, F is for FAD, L is for lipoic acid, N is for NAD, and Company is for CoASH. This reaction, the alpha-ketoglutarate dehydrogenase reaction, produces NADH, which is awesome because it's going to go to the mitochondria to electron transport chain and give us some money. You eat carbohydrate, they become glucose, it becomes pyruvate. Thanks to pyruvate dehydrogenase, there is the acetyl-CoA if you eat carbohydrate. If you eat protein, some of them will give you some amino acid that can lead to acetyl-CoA. And if the amino acid is leucine or leucine, it can give you branched chain alpha-keto acid dehydrogenase. If it's lipid, free fatty acid, and ketones, they go to acetyl-CoA. If it's ethanol, thanks to ethanol dehydrogenase or alcohol dehydrogenase, it gives you acetaldehyde. Acetaldehyde dehydrogenase gives you acetic acid. Acetic acid can give you acetyl-CoA, which will give you TCA cycle, and then it will give you ATP, which is money. There is an enzyme that jumps between acetaldehyde and pyruvates called pyruvate decarboxylase. What is the difference between a decarboxylase and a dehydrogenase? A decarboxylase means it just removes CO2 or COO. That's the whole idea of a decarboxylase. A dehydrogenase is different. It removes a CO2 plus it adds a coenzyme A. So, I have lots of amino acids, specifically leucine, branched chain alpha keto acid dehydrogenase, which is the same thing as saying branched chain amino acid dehydrogenase. And since it's a dehydrogenase, it's gonna kick CO2 into the trash and get us some coenzyme A. This will lead to this intermediate stuff that we don't care about now, and will give us acetyl-CoA, which we do care about because it's gonna go to the TCA cycle and give us ATP. It's also leading to acetoacetic acid, one of the ketone bodies. This can lead to a high anion gap metabolic acidosis. Acidosis inhibits the synaptic nerve transmission, so you'll be tired and lazy and not studying and watching Facebook or whatever you want to watch, or watching this channel. What are you doing with your life? Since this is a flippin dehydrogenase, it needs the 5 famous cofactors. It needs thiamine pyrophosphate or TPP or vitamin B1. It needs the FAD, NAD, lipoic acid, and CoASH, that Teflon company. Because misery loves company. Hexose monophosphate shunt is a whole other topic we'll talk about later, but in brief, here is the normal glycolysis. You eat carbohydrate, glucose, alright, whatever. A shunt is to shunt the glucose 6-phosphate here and bring it back here. See this? See how I did this, baby? Okay. We need 2 enzymes here. One is called transaldolase and one is called transketolase. We will talk about transketolase because we care about it, because it depends on vitamin B1, which is also known as thiamine. Do you care about the monophosphate or the diphosphate? No one gives a rip about the monophosphate. We're talking about the thiamine diphosphate, also known as the thiamine pyrophosphate or TPP. Quick summary before we talk about the clinical stuff. Thiamine, vitamin B1, cofactor in biochemical reaction, produces ATP. Dehydrogenases, it helps dehydrogenase, such as pyruvate dehydrogenase, alpha-ketoglutarate dehydrogenase, branched chain alpha-keto acid dehydrogenase, transketolase, and whatever. We are saying thiamine pyrophosphate. Phosphate is everywhere. If you like to learn about phosphate and other electrolytes such as sodium, such as potassium, such as calcium, and the normal kidney physiology and all of the stuff that drives students absolutely nuts, check out my course on my website called medicosisperfectionalis.com. I'm gonna give you a promo code for 60% discount if you just continue watching this video. Here are the enzymes that are aided by the great thiamine. Here's what happens when they are deficient. When you get pyruvate dehydrogenase deficiency, you can get lactic acidosis because now no one is taking pyruvate by its hand and makes it acetyl-CoA. In other words, pyruvate will just go astray and become lactic acid. What a horrible path in life. Lactic acidosis will lead to a high anion gap metabolic acidosis or HAGMA, which will make you tired, etc., and raise your anion gap. That's why we call it a high anion gap, if you make sense. Alpha-ketoglutarate dehydrogenase produces NADH, which is going to become energy in the electron transport chain. Some people say that Alzheimer's, Parkinson's, and Huntington's have some decreased level of alpha-ketoglutarate dehydrogenase. Branched chain alpha-keto acid dehydrogenase, if you are deficient, you can get a famous disease called maple syrup urine disease. Some medicoses biotep that are very colorful. B1 is the same as thiamine, helps in dehydrogenase, which is the same thing as saying oxidative decarboxylation, because we are removing a CO2 and adding a coenzyme A. This is a transfer of 2 carbon units, if you have noticed. B3 is niacin, helps in that redox reaction, reduction oxidation reaction. I should have colored this blue because it's the oxidation. Next, B6 is pyridoxine, helps in transamination. B7 is biotin, helps in carboxylation. B9 is folate, helps transfer 1 carbon unit, not 2, such as the famous thiamine. Some clinical pros, some nuggets of wisdom. Vitamin B1 is a cofactor of transketolase. Yes, Therefore, you can measure the vitamin B1 level by measuring the red blood cell transketolase activity. For instance, let's say you have a patient with vitamin B1 deficiency, such as the famous Wernicke-Korsakoff syndrome patient. You can measure their vitamin B1 level by measuring the RBC transketolase activity. Vitamin B1 deficiency can lead to many problems such as Wernicke-Korsakoff syndrome, biotin thiamine responsive basal ganglia disease, whatever that means, beriberi, and it comes in two forms, wet or dry, wet beriberi or dry beriberi. This is the same as Kentucky Fried Chicken. It's either wet or dry. Wet, we mean CHF, congestive heart failure, or dilated cardiomyopathy. Next, dry is neuropathy. Alcoholics are more liable to get vitamin B1 deficiency. We will discuss this famous song in the next video because this is clinically profound. Dextrose is also present in a solution called D5W, which you can learn if you go to my website and get my Electrolytes course. I compare between the difference between D5W, normal saline, half normal saline, what's the difference between hypotonic, hypertonic, and isotonic, and all of this crazy stuff. So please go to my website and get the Electrolytes course. Use the promo code Electrolytes60 to get 60% off your order. And this is only for 20 students. Thank you for watching. Please subscribe and join the tribe. Hit the bell to get notified. Follow me on these platforms. You can go to my website, please do, and get my Electrolytes course. Also, I have notes. You can download my notes that I'm drawing for these lectures. You can get courses. You can get cases. You can get one-on-one mentorship classes with yours truly. I'm going to help you pass your test, hopefully. Thank you so much for watching. As always, be safe, stay happy, and study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.